In the previous videos, we have been discussing how to name a complex, right? So in this part, we'll be discussing how to write the structure of the complex from the given formula. Okay, you will get the name, you have to draw the structure. Okay, so if you get a name like this, the first thing you should do, identify whether the complex is positive, negative, or neutral. It's very clear that there is two part, and how to identify that, you look at the metal. Okay, so here the metal name is like given as such, cobalt, which means it's a positive complex. Okay, suppose it is cobaltate, it will be a negative complex. So you're seeing like a metal name as such, so it's a positive complex. The counter ion is nitrate. Okay, so positive complex means the square bracket is first. Okay, so what is the counter ion? Nitrate. So just write the counter ion. Okay, so this type of questions you have to the main focus area is a counter ion. How many counter ions are there? Okay, that's a main thing you have to find out. Otherwise, it's like very easy to draw the structure. Okay, now which is the metal? Okay, inside the square bracket we have metals and ligand, right? So cobalt is a metal. How many ligand? You have amine, aqua, and chlorido. Three ligands. Okay, so how many amine? Like amine in the sense ammonia, right? NH3. How many ammonia? 4 ammonia. So CO NH3 4 times. Aqua means H2O. Chlorido Cl. So total 6 ligands, right? So coordination number is 6. Okay. Now nitrate. So NO3. Okay. Now what to do? So whether it is this is not the answer. You have to check the like whether the charge is balanced or not. Okay, so just look at the charge of the complex, find the charge of the complex. So what is the charge of metal? Is given +3. Okay, ammonia doesn't have any charge, water doesn't have any charge, Cl is -1. Okay, so what is the total charge of the complex? +2. So the +2 should be balanced by the counter ion, right? So it should be -2. What is the charge of NO3? The charge of NO3 is -1. Okay, so how many counter ion need? You need 2 NO3. Okay, to have -2 charge, you need 2 NO3. So what is the answer? The answer is CO NH3 4 times H2OCl within the square bracket, and the counter ion is NO3 twice. Okay, so this is the most important part. You have to find the number of counter ions. How to find it out? Find the charge of the complex. Okay, anyway, the charge of the metal will be given. You know the charge of ligand, find the charge of the complex. Okay, that should be balanced by the counter ion. So accordingly, you can have the required number of counter ions. So here it is +2 is the charge of the complex, that to be balanced by -2. So NO3 having -1 charge, so we need 2 NO3 to balance it. Okay, here we'll see more examples. Now, tris ethane 1,2-diamine chromium 3 chloride. Again, the metal name is given. There are two parts. So again, this is a positive complex. Positive complex. Positive complex means the coordinate part is will be first. So the square bracket is first. What is the counter ion? Chloride. So just put Cl. The number of Cl we can find it out later. Okay. What is the metal? Chromium. Okay. What is the ligand? Only one ligand. En. Ethane 1,2-diamine. How many? Tris. Tris means 3. So En thrice. Okay. Now what is the charge of the metal? 3 plus. Anyway, En doesn't have any charge. Cr is given +3. So what is the charge of the complex? +3. The total complex should be neutral. Like it's a neutral complex. Neutral complex means the total charge of the complex should be 0. It's not neutral complex, it's a positive complex, but the total charge should be 0. So +3 has to be balanced by -3. Okay, so how many Cl we need? 1 Cl having -1 charge. So to balance +3, we need 3 Cl minus. Okay, so this is the required formula. You don't need to show charges here, just this is the answer. Cr En thrice Cl3. Okay, so remember the number of counter ions. Okay, that number is doesn't matter, doesn't affect the naming, right? We already discussed that whether it is Cl or Cl2 or Cl3, that's not going to change the name. Okay, so the answer is Cr En thrice Cl3. How we got Cl3? Because the charge of the complex is +3, that has to be balanced by -3. So we need 3 Cl to balance the 3 positive charge. Okay, clear? Now, potassium tetrahydroxido zincate 2. Okay, zincate 2. So there is an ATE. So AT with the metal means the complex is negative, which means the square bracket is a second part. Okay, so what is the first part? Potassium. So just put the counter ion. Okay, we'll decide the number later. Now what is the metal? Zn, right? How many ligand? It's tetrahydroxide, so 4OH. 4OH. Okay, so what is the charge of the metal? +2. What is the charge of the total ligands? OH is minus, so 4 minus 4. What is the total charge of the complex? -2. The -2 has to be balanced by +2. We know the charge of potassium is +1. So to have +2, how many potassium we need? 2 potassium. Okay, no need to show the charges. So this is the answer. K2, Zn, OH 4 times. So only the number of counter ion to be, you have to find it out from the, like, finding the charge of the complex. Okay. Now, next one. Sodium trioxalato-ferrate 3. Again, you can see a metal with AT, so it's negative complex, which means the coordination part is the second part. Okay, so the square bracket is coming second. So what is the positive part? Sodium. So just write Na now for the time being. Okay, now what is the central metal atom? Fe. What is the ligand? Oxalato, C2O4. How many oxalate? 3, so thrice. Okay, what is the charge of C2O4? It's a bidentate ligand. Okay, -2 charge. -2 charge. Okay, so how many C2O4? Like there are -6 from oxalate. Okay, +3 from iron. It's given. What is the total charge of the complex? -3. That to be balanced by +3. What is the charge of Na? Its first group element is always +1. Okay, so we need 3 sodium to balance the -3 charge. So what is the answer? It's Na3 FeC2O4 thrice. Okay, so only the number of counter ion to be taken care of. Okay, so that only to be like that has to be find out from the finding the charge of the complex. Okay, now last one, this is an important one. Okay, it's not that easy like the other examples we did. Okay, so here iron 3 hexacyanide of ferrate, again AT, right? So it's a negative complex. But here outside also the counter ion is also iron, right? So the square bracket is second. The outside counter ion is iron. The central metal is also iron, right? Central metal is also iron. What is the ligand? Cyanide, hexacyanide, right? Cyanide. Okay. Now find the charge of the complex. Okay. Fe inside is 2 plus. What is the charge of Cn? It's -1, right? Cn is -1. So cyanide, what is the total charge? -6. What is the total charge of the complex? The total charge of the complex is -4. Okay. So what is the charge of the iron outside? +3. So if you add these two charges, okay, it's not neutral, right? +3 plus -4. It's not 0, right? It's not 0, but it has to, you have to make it 0. So how to make it 0? So it's 3 and 4, right? So go for LCM. What is the LCM of 3 and 4? LCM of 3 and 4. It's 3 into 4. Okay, it's 12 is LCM. Okay, so make it 12. So one Fe has +3 charge outside. So to make it 12, how many Fe we need? We need 4 Fe, right? So 4 into 3 is +12 charge. Now 4 Fe means what is the total charge of the counter ion? +12. Now what is the total charge of complex? -4, right? So to make it 12, how many complex we need? 3 into 4 is 12. So 3 like complex ion we need. So 3 into -4, -12. Now +12 -12, it's 0. Okay, so this is the answer. Okay, you don't want to like remember in naming this subscript out like outside the coordination sphere and like outside the for the counter ion, the subscript is not important at all. It won't affect the naming. So what is Fe4, FeC and 6 times. So somehow you should balance the charge. So find the charge of the like coordination part, the complex ion. Okay, the charge of the complex that should be balanced by the counter ion. Okay, so somehow you can use put suitable numbers. Okay, to balance the charge. Okay, so the answer for the fifth one. Okay, so this type is important. You have a similar type is given on the sample paper also. Okay, so I hope it's clear. Thank you so much.